Today we're going to take a look at implicit derivatives. Before we get on to this question here, we're going to take a look at something a little bit easier. So this one here, x squared, y squared, those two terms, and we have to try to find the derivative of this function. So one way you can do it is look at the explicit. So what we can do is substitute x in for y. So we'll have to rearrange that first equation and make it in terms of y. Okay, so now we have two possible values of y, and what you can do is just directly substitute that into the equation above. So that would be our equation, and then you can just solve for x there and find the derivative of x that way. It is a little tricky, it looks kind of hard, but it's still doable. But let's look at the implicit way of solving this problem. So we have our equation for a circle, and what you want to do is take the derivative of both sides, or take the derivative of all of the terms in this equation. So let's use the summation rule and take the derivative of all the terms here. So we can see that on the right-hand side of the equation, the derivative of 1, that's pretty easy to solve. That's just going to give us 0. Looking over on the left-hand side, if we look at the left-hand term, so or d over dx for x squared, we just take the derivative of x squared. So that just leaves us with 2x. The second term, y squared, that's a little bit tricky. So what we're going to have to do is apply the chain rule. So when you think of implicit derivative, think of chain rule. So that is just like saying the derivative of y with respect to x. So with the chain rule, we're going to solve for the outer part first. And in this case, you can almost ignore the info that's inside of the brackets and just solve for the outer. In other terms, it's just like having an equation where you really don't know what's inside that bracket, but you're assuming that there could be an x value. So when you solve for this, you just get 2 plus whatever is inside the bracket. And we say that is solved. In other words, it's like a closed box. We assume that there's an x function inside of it that we need to solve. So we perform the outer operation. And it's important to note that d over dx is an operation itself, just like plus, minus, divide, and so on. So when we perform this operation, we'll get 2 times the box. Time to open the box. So we get 2y. So since this is chain rule, we have to multiply 2y by the inner function. And that inner function is y. So what this says is to find the derivative of y in terms of x, but there is no x present, so we can't go any further. So this just gives us dy over dx. So now we have our 2x, our 2y, times the inner function, which was dy over dx, and that is all equal to 0. So now let's isolate dy over dx. So we have to subtract 2x from both sides. So dy over dx is equal to negative 2x over 2y, which can be simple to negative x over y. So remember, derivative can also mean slope, or your tangent, or your rate of change. So let's try to find the slope of the circle when x is equal to 0.5. So you might recall the unit circle. When x is equal to 0.5, what does y equal? That's going to be root 2. So let's plug that into our equation. That gives us approximately negative 0.35. That will give us the slope of the purple line here going in the negative direction at approximately negative 0.35. So now it's time to tackle this question. So how many terms do we actually have in this whole equation? Well, let's count. There's 1, 2, 3. So let's solve for d over dx for each of these terms. Starting with the far right term, d over dx for x, that just gives us 1. Looking at the green term, d over dx for y squared. So we're going to have to apply chain rule for this. So our outer function is just something squared. So that gives us 2y. So we don't know how to find the derivative of y because there's no x in that function. So it just remains 2y times dy over dx. Now for the left-hand function. If we kind of look at this as if all the variables are x, what rule do you have to apply to solve this? So that's going to be product rule. So recall that product rule is f of x times g prime of x plus g of x times f prime of x. So let's solve for these individually. So f of x, that's just going to be x squared. Let's look at g of x. That's just our sine y. F prime of x, that is 2x. G prime of x, saving the best for last. So we're going to look at the outer function first, which is just sine something. What's the derivative of sine? That's just cos. Now we have to multiply that by the inner function. So you can see here that we're applying chain rule. Since the inner function is y, when we try to find the derivative of y, it's just going to be d over dx times y. So we can move that y right beside that d. Now let's sub in what we got for our product rule. So at this point, we're going to try to put all the dy's to one side and all the other terms to the other side. So we're going to isolate dy. So we see that we have a dy here and a dy here, and we can pull those out. So now we're just going to divide both sides by the term on the left. And that is our answer. If you guys have more questions on implicit derivatives or what I did here, leave a comment below. Subscribe if you found this helpful, and stay posted for new videos. Thanks for watching. Have a good one.